two tails, what I want to say is, if I say a sample space of tossing a fair coin for 2 times, what will be the sample space? Everybody knows HH means two head, HT means one head and one tail. Tail head and another one is TT, tail tail. And what does it mean by H? H. This is two head and this two is for one head and this is zero head because here is no head. Thus, the number of heads obtained in 3 toss of the fair coin of a random variable that assumes the value 0, 1, 2, 3. But why? 3 means H, 3 times head. 2 means head is 1, 2 times and other is T. That can be in various cases. That can be H, T, H, T, H, H. Okay. And so on. And 1 means H is 1 time. Like that, HTT, THT, TTH, and 0 means no head. And now we can say there is sample space of tossing 3 times of a fair coin. Fair coin. Slip of tongue. Fair coin. Sorry. Now 3 times means sample space is 2 to the power 3, that is 8. Why 2? This is number of outcomes. And 3 means tossing 3 times, number of tossing a fair coin. Now 2 to the power 3 is just nothing but 8. And the respective probabilities. What is the probability of means probability means P probability of getting getting 0 head. What is that? 1 by 8, because H, here you can see H, that is probability 1 out of 8 sample space. So 1 by 8, this is the number I have written. Next, probability of getting 1 head, that is 3 by 8. You can see I can copy or paste this. Acha, 1 head na, 1 head, that means this one. And probability of getting 2 head, that is also 3 by 8. Why? You can see here also these. And the last one is 3 head, that is 1 by 8, that is nothing but TTT. So here is the thing. A random variable which can assume a finite or countably infinite number. Random variable কি জিনিস? What is the thing? Uh, what is the main actual thing random variable is? That is nothing but a variable can assume a finite or countably infinite number. Finite and countably infinite number. So this is called discrete random variable. We know what is discrete variable, right? Discrete variable means if I say 1, 2, there is many values here, and if we say number of persons or individuals in a family, what will be? That must be 1 or 2 or 3 or 4. That can't be 4.59. That can't be. This is the all isolated value. So isolated value, this term is important to say the definition of discrete random variable. And as same as that, what is continuous random variable? There is nothing but that can take any value in a certain range of number. That means 1, 2, 3, 4 and 5. If I say 1 to 5, that is the range 1 comma 5, and that can take any value like 3.9856 dot 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 dot. That can be goes on. What is continuous random variable? Example, take an example to understand easily. Today's temperature is like 42 degree 5 42.57 degree centigrade. That can't be finite, lol. So 42.57 degrees centigrade at Rajasthan. That is continuous random variable. That can take any value in a certain range of values. So continuous random variables is got the chance to take any value. This term is important. So let's get started with probability distribution, expectation and variance of random variable. We will discuss one by one in this video. So let's take some sorry, this is technical issues. Probability distribution, expectation and variance of a random variable. Random variable, this is so let's get started with the topic number illustration number 1. If a fair coin is tossed twice, a fair coin is tossed twice. The number of heads obtained that is denoted by x will have the following probability distribution. And let's create a table. Value of x, this is value of x, this is, sorry, this not be done, this should not be done, value of x, this is probability of x is equal to x, this is small x and this is capital X, 0 1 by 4, 1 1 by 2 and 2 1 by 4. And we everybody knows what is the total probability of anything. Total probability of anything is always 1, because probability means some value and some value, and this is sample space, and this take any value between of among of sample space, and if this is 5, this can take 1 2 3 4 5, and if this value is, this is the probability of these values, if we add them, what we'll get, we'll get 1, because if this is an biscuit and if I say this 10, and we can divide it in some quantity, means 1 1 1 1 1 5, so 5 in 5 ways this is divided, so if we add these parts, these, what we'll get, we'll get the total full part of the biscuit. This is actually probability. And the important feature of random variable is expectation, and here the expectation we are going to know. The expectation of random variable x denoted by ex. Expectation. Let's get started with expectation. Of a random variable x, this is short form of random variables, we can use it. Random variable x is ex. What is this? This is expectation. And the expectation of random variable x is denoted by ex, and or mu and subscript s serve as measure of central tendency of probability distribution of x. This, what is this expectation? This expectation is actually nothing but a mean. What is mean value? Mean value, if we say 1 2 3 4 5, this is the mean value. Expectation give this same exactly value. So if x assumes some values, if x assumes some values like x1, this is all small, all in small, x1 x2 dot dot dot, with respective probabilities, means x1 have the probability, x1 has the probability p1, x2 have the probability p2, and dot dot dot, xn has the probability pn, and where summation p1 is 1, we know the all probability, this is probabilities, we know all the probabilities, if all the probabilities are added we get 1, because the sample space takes the, you know it. And expectation of x is xi pi, provided this is finite. So what is the definition of expectation? This is the definition of expectation, means the definition of expectation is, sorry, summation xi pi. This actually behaves like xi fi, but this is not exactly mean. This pi behaves like fi. And what is the behind story of expectation? We are going to know. Note there is a note, say gx is the function, is a function of x, and expectation of function gx is nothing but gxi pi, because here x is substituted by gx. There is no basic difference. So for example, we can take a illustration to give a clarity. This is about you. For example, if x takes the values 1 and minus 1. What is this? 1 and minus 1. With respective probabilities, this is the probability 1, 2 by 3. Let's write it in words. With respective probabilities, we can use prob and dot to denote probability in short form. 2 by 3 and 1 by 3. Then expectation of x is, let's get started with this formula. We have to use it here. So gxi and pi. Let's see what is the formula of this one, probability of n. That is nothing but xi plus xi pi x1 p1 plus x2 p2. And what is the x1 in this? This is 1. And what is the x2? This is minus 1. And p1, what is the p1? 2 by 3. And what is p2? 1 by 3. This is nothing but by 3 minus 1 by 3. 1 by 3. This is our expected value. This is nothing but this is mean.